Hello everyone, welcome back to the YouTube channel and my name is Rahul. .NET Core supports a logging API that works with a variety of built-in and third-party logging providers. Logging providers usually store logs except for a few like console which displays them. In this video, we will learn more about the built-in logging providers in ASP.NET Core, how they are configured, and how you can use them in your application. Heading off to my console, let's use the .NET CLI to create a new ASP.NET Web API application. This is going to create a new Web API application into the current folder. Let's open this application in an IDE. I will choose Rider in this example. You can choose whichever IDE that you normally use to work with .NET applications. The project is loaded here and it has a program.cs and a startup.cs file as expected. It also has a controller, which is the weather forecast controller. To start with, let's first create a log statement in this template. To do that, let's go to the weather forecast controller. In the constructor, we see that we have an ILogger of weather forecast controller already injected in. However, this is not getting used at the moment. So let's make use of this. So let's write _logger and specify the log statement and give in a log level. So in this case, this is basically an information and it needs a message for this particular log. Let's say hello from weather controller. Let's put a breakpoint here and run this application to see how this works. The application has started and it has automatically called the weather forecast endpoint. We have the breakpoint and it's calling the logger.log method. So let's step into it and go to the console to see that particular message coming up in the console. We have successfully written a log message to the console provider. Let's see how this is working under the hoods and how it started logging into the console provider. Let's stop this application and go to program.cs. In the create host builder method, we call a host.createDefaultBuilder. This is a framework provided method that we are using to initialize the builder. Let's see how this createDefaultBuilder method is implemented. In Rider, I can simply use F12 to go to the definition and it will automatically disassemble the source code for me. If you are on a different IDE, you can also configure this there. However, Rider provides this by default. Alternatively, you can also go to the GitHub and view the source there. Let's scroll down in the createDefaultBuilder and go to the place where the logging is configured using the configure logging method. This first checks if it is a Windows environment and it adds a few filters in that case. After that, it sets up the configuration for the logging, which is basically reading from a section called logging, which we will come later in this video. This is where it is setting up the default logging providers. You can see it's setting up the console, the debug, the event source logger, and if this is Windows, it also sets up the event log provider. So by default, ASP.NET Core template is setting up 4 providers for this application. This is the reason why we could see this message in the console when we ran the application before. You can override the defaultly specified providers in your program.cs class. So let's head back to program.cs and after the configure web host defaults, you can add in an extension method which is the configure logging method. So this takes in a logging builder. So let's use that and then we can start operating on that builder. You can call the clear providers, which will clear off all the logging providers that's registered into this builder. So let's call that for example and let's run this application again. In this case, we should not be seeing the log message in the console because there are no providers that's set up for this application right now. We have hit the logger. However, running that statement doesn't produce any logs in the console right now because we cleared off all the providers. You can call in the builder.addConsole, which is going to add the console provider. This should start logging in back like we saw before. So running this, we now have the hello from weather controller message back in the console. Let's look at what's happening in the weather forecast controller. It takes in an ILogger of weather forecast controller, which is injected in using the dependency injection service. If you want to learn more about dependency injection and how that works in ASP.NET Core, check out the video linked here or in the description below. The weather forecast controller type is basically specifying the category for that logger. Once we have the logger instance, we use the log method on it to write the message into the logs. Here, we also specified a log level, which is an enumeration In this case, we use the log level dot information, showing that this is just an information message. The category set on the ILogger is simply an arbitrary string. By convention, it's usually set to the class name that the logger is used in. So in this case, it's using the ILogger of weather forecast controller. But since this is in convention, there's nothing stopping us from using this as a different value. Let's say, for example, instead of iForecast controller, we can inject in an ILogger of weather forecast. Make sure that we have the read-only property also reflect the same type, and then use this for writing the messages. So if we were to run this is now going to use the weather forecast as the category, which you can see here in here logging, and it specifies logging.weatherForecast. So this is the fully qualified name of the weather forecast class. If we go into the definition, you can see this belongs to the namespace logging, and the class name is weather forecast, which is why you see here as logging.weatherForecast. If we go back to the weather forecast controller and change this back to weather forecast controller, we can see it should now start showing the weather forecast controller as the category. Let's rerun the application, and we see this time the category is logging controllers weather forecast controller. The log level indicates the severity of the log. This is an enumeration which has different values. Let's go to the definition of that, and we can see it has different values: trace, debug, information, warning, error, critical, and none. This is in the order of severity of the log level. So let's go back. Instead of using the log method and specifying the log level explicitly, we can also use the extension methods that's available as part of the logger class. So we can specify logger and specify log information, which is exactly as specifying the log level dot information, and give in the message hello again from the controller. So if we run this is going to look exactly same as the line before, because we've used the log information extension method to specify the log level information. So if you see, we have the same logging info controller, and it's specifying info on both the cases. So here we have the category set to the exact same value. If we go into the definition of log information using F12 in Rider, we can see that it uses the logger.log method and calls in the log level.information for us and passes on the message and the arguments if there are any. Similar to the log information, we also have extension methods for the other log levels that we saw. So if we use the log method, we can see we have log information, log error, log trace, log warning, log critical, and log debug methods. This sets the appropriate log levels when creating the log messages. So if we were to use the log warning, for example, and say this is a warning, that's going to set the log levels to warning. So let's run this and see how that's represented in the console. You can see that this has created a new warning message, which is saying this is a warning. Note the color coding here to indicate that it is a warning. You can also log exceptions using the log error method. Let's create an exception here and try logging that. So in this case, let's add a try catch block. Instead of the default console.writeLine, we can remove that and create a logger statement. So let's say _logger and specify log error. This takes in an exception as its object and also a message. So we can say error in creating object. Let's throw a new exception and say this is a test exception. Let's run this and see how that appears. The exception is now getting logged and it shows a failure message in the console. It also logs out the error message that we specified and also the details of the actual exception that occurred. Each log can have associated an event ID. An event ID allows us to group different logging messages. So let's say all our get methods have a specific event ID. To specify an event ID, let's use the logger and use the log information method and specify an event ID to start with. This is simply a number that you can specify. So let's give 1001 and then give in a message. So getting weather forecast details. Let's run this and see how the event ID appears in the console logger. As you can see, it's logged out this message here, getting weather forecast details, and you can see the event ID specified in the brackets in the console provider. Depending on the provider, it might choose to log this or also ignore this. Some providers also save this as a separate field, which allows you to query and filter on these log events. Rather than hard-coding the log IDs in here, you can also use this from a shared class or from a constants class however you want to manage them. The log message specified here is a message template and it can take in parameters. To do that, use a curly bracket and specify the parameter name. Let's say count, and then pass in the parameters as values after the message. We can pass in a 5 in here, so this will be replaced by 5 when the log is written. Let's run this and make sure it's working as expected. We can now see the message here getting weather forecast details, and it also shows the number 5 which was replaced in here. This gets replaced in the order that the parameters occur. So you need to make sure the order in which the arguments are passed in is correct. Let's say in here, if we have a P1 and P2 getting passed into the message template, the order is important. So if we specify P2 first, even though this is P1 that's coming up, it's going to pass in the P1 value for there. If we run this, we can see the value is coming as parameter 1 and parameter 2, even though the template specified the parameter 2 to be first. To fix this, we'll either need to fix the template or the way in which we are passing the parameters. So I'll simply make this as P1 and make this as P2 to fix this in this particular instance. These arguments are passed on to the different logging providers and not just the string template, which enables them to do whatever they require. Let's see this for an example by adding a different logging provider. For this example, let's configure an external provider which is called Seek, which helps us to visualize logs in a much better format. If you have not used Seek before, I highly recommend checking it out. You can run this on your local machine by downloading it from here. Once installed, you can use the Browse Seek shortcut in your Start menu or explicitly navigate to localhost 5341, which is the default port where Seek gets installed. So this loads up a visualization to see all the logs. Let's see how we can configure ASP.NET Core to log to Seek as well. As you would expect, we need to install a NuGet package. So let's go to the project, right-click the project, and say Manage NuGet Packages. We need to install the Seek extension.logging library. So this is seek.extensions.logging. So let's install that to this project. That is successfully installed. So let's go back to program.cs, where we first cleared all the providers and added in the console. So here we can now specify builder.add_seek. This is now provided by the NuGet library that we just installed. Once we set this up, we should be able to visualize the logs created by this application in our local instance of Seek, which it is defaultly configured to. You can override the server details in here using parameters. However, I will leave it to default and use the localhost 5341 as itself. Let's run this and make sure everything is working as expected. The application is now running. If we go back to the console, we can see all the log messages that it has generated. It has also created the errors and the warnings. Let's head off to Seek and refresh this to see it reflecting in here as well. So we can see some messages here, which is the hello from weather controller that we wrote, the hello again, the warning message and the error objects, and also the parameter values. If we were to click that, we can see more details that's associated with that particular log message. We specified in the getting weather forecast details, we specified an ID and a count. So let's go back and see how that is getting represented. We have the event ID specified here, which is 1001, and also the count that appears as an attribute that we can filter on. The message is as expected as in the console message. Similarly, for the parameters, we have the values for P1 and P2, which was passed into the template. This is basically an example of structured logging. If you want to know more, check out the link in the description below. This now allows us to filter these logs quite easily. Let's say we want to see only the ones which has a count of 5. So I can come here and click and say find with any value or specify find, which is going to say which is only having the property count is 5 and it just displays one of the log message. Now that we know how to configure providers and also write log messages, let's see how we can control the amount of logs that gets written on different environments. Using the appropriate log level is the most important thing. When writing a log level message, make sure you use the correct log level for that particular message. In the end, the number of messages that get stored is also equating to money because you need to pay for storage. We can use the logging configuration to limit the kind of logs that gets written to a particular storage based on the environments. Logging configuration is best specified outside of code as config files. We had seen in a previous video how to specify configuration in ASP.NET Core. Check out the link here or in the description below to get more details. By default, the ASP.NET Core specifies the logging template in the appsettings.json file. So let's go to appsettings.json and we can see the logging configuration here. The logging property in the config can have the log level and also the log provider properties inside it. By default, only the log level is specified. Any default message is configured here to be information. Each of these values under the log level specifies a category and an associated log level that needs to be logged for that category. So in this case, anything that is information or greater than information log level is going to get logged. When we saw log level, we had seen how the severity was ordered. So when anything is greater than information, which means information, warning, error, critical gets logged for that particular provider. So here, this is the default. So any default log message is going to log only above information. So if we have a trace log, it's not going to get logged in this particular example. So let's go back to the weather forecast controller and add in a trace log to test this out. So let's specify log trace, which is going to add the log level as trace and say this is a trace message. Now since the config specifies only logs with a level of information or greater needs to be logged, this is going to get ignored. To get this to work, let's update the configuration. Since this is running in the development environment, we need to check the appsettings.development.json file as well, which also specifies a logging configuration. So let's modify it here because this is going to defaultly take precedence over the logging that's specified in appsettings.json. So let's change the information here to be trace. So this is going to start logging any messages that's trace or greater than that. We can now see we have a trace message and that this is a trace message is logged in the console. The logging configuration can also be overridden based on the provider. So let's say in case where it is a seek provider, we don't want the default to be trace but to be information. So let's use seek to specify the provider and give in the logging configuration for that. Once we have the provider name, we need to specify this exact same structure below that. We can turn this back to information. Since in the previous run we didn't have this configuration, seek would have written that trace message as you can see here. Let's keep a note of the time here which ends with 202 and now we can start running this, which should not log this anymore because we have overridden the config for seek. So let's run this application. As expected, in the console we still see that trace message. However, if we are to go back to seek and refresh this, we'll not see a trace message. So you can see that this is a trace message no longer appears here in seek. This is because we use the configuration to suppress that particular level for that particular provider. The values that appears here are basically categories. So if we want to override for the category that we have just written, we could do that as well. So let's specify the category logging.controllers.weatherforecastController and use that to override the levels for this. So we can give in a log level that needs to be logged for this particular category. So let's specify only errors should be logged for this category. So we can specify error and run this application to check if everything is working as expected. And now you can see that for the logging controllers weather forecast controller category, it's only logging the error messages. This is because we have specified in the config that only error log levels must be written. Let's change that back to information so that all messages gets logged. You can use a logging scope to group a set of logical operations. This allows us to add common attributes or properties into that particular scope. To use a logging scope, we can use the _logger and specify the begin scope method. This takes in a dictionary of objects, which can be any values that you want to attach with this particular scope. So here I have specified a person ID with this particular scope and also logging two messages, which is hello and world, which are information. Let's run this. We can see in seek these two messages appearing. So we have world and hello. And note that the person ID gets logged for both these log messages. So you can group these different logs to be part of a single operation. So if you have an HTTP request context or a particular transaction that you are trying to track across multiple log messages, you can use this to group a set of logical operations. For the console provider to log this, you need to explicitly enable it in the configuration. If you want to write a log in the startup class, you can inject in an ILogger or startup into your configure method. To do that, go to the startup class, and in the configure method, you can inject in like here. And you can specify the logging messages like we saw before. So we can specify log information and say from startup class. Note that writing logs before the completion of the dependency injection container setup is not supported, which means you cannot inject a logger into the startup constructor nor into the configure services method, which basically sets up the dependency injection. By default, ASP.NET Core includes these logging providers, which allows us to log to the console, debug, event source, event log, Azure App Services, and also application insights. You can also use third-party logging providers like Serilog, Elma, or Log4net for example. Integration is quite easy, and it's very similar to just calling an extension method like we did for adding the seek. Make sure to check out this blog post, which will be linked in the description below, which provides some good recommendations and practices when using the logging library. Hope this helps you to understand more about logging in ASP.NET Core. If you like this video, please make sure to hit the like button. If you want to be notified in the future of similar such videos, please make sure to subscribe. Thank you and see you soon.